Hi, I'm Jürgen Strauss from InnovaBuzz, and welcome to episode number 4 of the InnovaBuzz podcast, the podcast designed to help smart business owners with an interest in innovation and the Internet of Things become even more productive. Now, today's guests are Derek Buckmaster and Steve Atkiss from Carbon Nexus in Geelong, Australia, and they're going to tell us about their brand new open access research facility dedicated to carbon fibre research. This facility is set up to take advantage of the world's leading scientific expertise at Deakin University in advanced composite materials, combined with a state-of-the-art pilot production facility that they've built out there that gives the researchers the ability to develop materials, conduct experiments on the pilot line, and improve materials and the processes at the same time. Now, both Derek and Steve emphasize in the interview that Carbon Nexus are not just about carbon fibre, but about providing solutions to their customers. They talk about the techniques that they use in the research and development community to generate new ideas and to be more innovative. And in particular, Derek highlights the 5 whys technique. So today's innovation tip, is indeed based on the technique of the 5 whys. This technique was originally devised by Toyota as the basis of their scientific method in the 1930s, but it was not widely used until the total quality movement in the 1970s. And then it gained a lot more popularity as one of the tools within the Six Sigma methodology, but in these cases both as problem-solving tools. Now, our tip, though, is to use 5 whys as a technique for developing new ideas. And the way this works is that once you've defined a problem or a need that you wish to expand on or wish to explore in more detail, you ask why 5 times. Now, each why begins with the answer to the previous question. At the end of the 5 why questions, you're likely to have a whole new perspective on your problem or need and have generated another approach or new ideas around that. For example, let's say that you have a software application that's not getting a lot of paid users. And in our example, the company decides, well, let's just put a whole lot of social apps linking into that, and that's going to get us a lot more social users. So the 5 whys technique would begin with, why are you adding these social sharing buttons or these social apps? And the answer would be, because we're looking for more users. Why are you looking for more users? Because the existing users aren't converting to paid users at a satisfactory rate. Well, why is that? Because they're not engaged with the product. So why is that? Because training in the use of the product is poor and the users abandon our application at a very early stage after trying it out for only a short time. Okay, well, why is the training poor? Because we've been too busy ironing out the bugs in our software to develop the training. So you can see where this is leading. Adding social sharing buttons or social apps may not get us the result that we want. However, focusing our time and effort on ironing out the bugs and developing the training probably will have a much greater effect on achieving our desired result. So take a look at the 5 whys technique the next time you're developing ideas or solutions to a need. You might be surprised how powerful this indeed is. Now, before we meet Derek and Steve, I'll just announce this week's competition. The prize this week is sponsored by InnovaBuzz, and it's a copy of our 7 website design secrets to get you more sales. That's a video series together with a workbook and a resources guide. So stick around for details on how you can enter the draw to win that prize later on in the video. So stay with us let's get into the innovation hive and get the buzz from Derek and Steve at Carbon Nexus.
This is the InnovaBuzz podcast, helping smart businesses be even more innovative.
Hi, I'm Jürgen Strauss, and I'm pleased to have here with me today Derek Buckmaster, who is the Director of Carbon Nexus in Geelong. So welcome, Derek. It's great to have you on the InnovaBuzz podcast.
Thanks, Jürgen. It's good to be here.
Now, today we're going to be talking about all things innovation in advanced composite materials and how to build a business from an idea, a technology, and an expertise. But before we do that, a quick competition announcement. So I'm going to be giving away a copy of my workshop, 7 Websites Design Secrets to Get You More Sales. So it's a video series together with a workbook and resources guide. So stay tuned later on in the interview to find out how you can enter the draw to win that prize. Okay, Derek, so before we learn a little bit more about Carbon Nexus and some of the fantastic things you're doing out there, tell us a little bit about your background. When you were a young child, what did you want to be when you grew up?
Well, strangely enough, when I was a really young child, I wanted to be a truck driver. Myself and a few of our mates were always in awe of the big Freightliners and Macs and white trucks that were driving around in our area. So that was the epitome of power and prestige to us.
Okay.
I pretty soon moved on to architect and then airline pilot.
Okay, airline pilot. So that's an interesting transition from trucks to airlines.
It was. But again, it was, pretty much the glamour of driving a 747 around.
Yeah. So where did the journey take you then?
Well, I always enjoyed making things, and I guess I picked some of that up from my father, who was a very hands-on sort of guy. So I ended up studying engineering after leaving high school, and getting into a number of different and interesting areas based on being a mechanical engineer.
Okay. And then you got into the advanced materials industry very early on, right?
Yeah, well, when you make things yourself at home, you end up using composites even without knowing it, because of course, wood and glue. But the sorts of things I was making, which were model aircraft and boats and things like that, actually, needed composite materials to start with. So very early on, I knew what advanced composites were. My career as I came out of university, I started work with a manufacturing company in Australia, manufacturing heating equipment. So that was a very interesting introduction to industry. Yeah. And then moved into a research position with a state government department at the Werribee Research Farm, where they were doing some research into aerial spraying of crops. And then that was pretty interesting. And then an opportunity came up with General Electric to go and train and do some work overseas in CAD/CAM. And of course, that was around 1986, 87, and CAD/CAM was pretty interesting. So I jumped at that opportunity.
Yeah, well, that was one of the big new things there, wasn't it?
It was indeed. Yeah. Yes, and we were using some fairly advanced computers, and even though they were advanced, we would often have to wait overnight for a job to complete and come in the morning to see what the results looked like.
That's right, and if you made a mistake in the programming on the way, you'd only find out the next day, wouldn't you?
That's right. You had to start it again.
Yeah.
Exactly.
Yeah. So when did you kind of get involved in the carbon fibre industry and advanced composites of that nature?
Yeah, well, advanced composites of carbon fibre really happened about 6 or 7 years ago. I'd been working for the plastics business in General Electric, and that whole business was acquired by a Saudi-based company called SABIC. And I moved across to the headquarters of SABIC at the time and started working with them on building several new businesses, and carbon fibre was in my portfolio. So that was when I was really introduced deeply into carbon fibre. Okay. And so we were tasked with building a 3,000-ton carbon fibre plant, and essentially from scratch. So that was the the interesting project that kicked it all off.
Yeah, well, that would have given you an insight into everything around the whole thing, right from sort of the material itself to how to produce it to building a big plant, right?
Absolutely. We had to learn about the market. We had to learn about the product. We had to learn about the technology. So, Subic is a business that grows by acquiring technologies, and they do a great job of that. So the very first thing we had to do was go out and find who could offer us technology for producing carbon fibre.
All right. Well, that's a good transition. So tell us a little bit about Carbon Nexus then.
Well, Carbon Nexus is an interesting centre. It's essentially an open access research facility which is based in a university. It's open access because it's intended that industry should come and spend a lot of time and looking at how to solve their problems using the equipment and the capabilities that we've created here at Carbon Nexus. It's really the only facility of its type in the world. There's a similar facility in the US, but it's not quite so open access, and it's not in a university environment where there's a fundamental research going on. So the idea really came up. Dr. Bronwyn, Associate Professor Bronwyn Fox, and Brad Dunstan. Bronwyn was from Deakin, had done a lot of work in advanced composites over many years. And Brad Dunstan is at Victorian Centre for Advanced Materials Manufacturing. Together they had this vision of introducing a new research capability which would not only put Australia at the forefront of advanced composites research, but it would also offer opportunities for local industry to really get into advanced composites manufacturing, both including the fibre itself and also composite parts. And the idea grew about 3 or 4 years ago. It grew and developed. They found some backing from state government and from federal government and from the university. And they basically worked from there and generated a team of experts, specified what the facility should look like, and built it. And I guess I've started about a month ago, and one of the beneficiaries really of all of the work that Bronwyn Fox and Brad Dunstan put in to get the centre up and running. Yeah.
Now, I had the privilege of actually touring through the centre last week, and it really is a state-of-the-art facility, and it's a pity we don't have Steve on the interview, Steve Atkiss, who's the general manager and who's the brains behind the pilot line that's out there, and certainly Bronwyn. Now I'm going to interview Bronwyn Fox, who Derek has mentioned. I'm going to interview her in a future thing, so we'll learn a little bit more about the research from her. But tell us a little bit about the pilot line facility out there.
So the pilot line facility, again, this is unique. It's a carbon fibre factory. It's a small scale factory. We have the same equipment which is installed in large scale factories around the world for industrial scale carbon fibre production. Our factory is slightly smaller scale. It's not as wide and it doesn't have quite the same capacity. But if you walked into a carbon fibre factory, you would recognise all the same equipment. Yeah. So what that gives us the ability to do is to really solve a lot of the problems that industry has in processing and manufacturing the carbon fibre itself. And alongside the pilot scale line, we have a single, what we call a single toe laboratory scale line, which is also, in a similar vein, can be used for solving problems and answering questions, but is also very useful for very basic research where you want to try out something completely new that you're not even sure will work. And so we've got these two pilot lines side by side, both focused on researching into the challenges and the issues around the industry. And a lot of those issues are around how to reduce the cost of producing carbon fibre. So we focus a lot on reducing the amount of energy which has to go into the process for manufacturing the fibre. And we also are looking at how we meet the challenges of improving the performance of carbon fibre. And that might be making it stronger or lighter, but it also might be actually just targeting the properties to achieve a certain performance level, rather than making it super strong or super flexible.
Yeah, and what I really like about the whole setup there, and is there is this really state-of-the-art pilot facility as you've described, associated with the fundamental research, and the people doing the fundamental research are actually learning how to run the line. So I was told that the researchers will actually run the line, they'll understand the process better, and their fundamental research then will not only address the fundamentals, which a lot of time the research and the production and the reality is a little bit separate. So here it's all integrated. So it's a really beautiful model.
That's quite right. We bring the researchers into the industrial type of environment, and they understand it. And really, for the first time, I think researchers have the ability to access this sort of equipment at a fundamental level and also at an industrial level.
Yeah. And the other thing I like about that model is it leverages the know-how that you have out there with the intellectual capability, the ideas and the experience and know-how, together with the production facility, in a way that can be a competitive advantage for Australian industry.
It can indeed. It can indeed, and that's in fact one of the big challenges now that we've got is the know-how and the people and the research which is going on here at Deakin is really world class. There's groundbreaking research in advanced composites, both in producing carbon fibre from the very fundamental chemistry that's involved, through to the processing issues on production lines. All the way through to advanced composites and how they're used in different applications, from cars to aviation to wind turbine blades. So it's a unique facility. There's world-class work and research going on, and our goal and our challenge is really to connect that research capability and those wonderful researchers with local industry and with global industry to make an impact in the industry.
Yeah, and there's a huge opportunity there for industry, but we're constantly bombarded in the press about bad news and about industries going under. But here's a really good news story that's exciting and that has all those possibilities that you've mentioned. So, indeed,
and we want to be a catalyst. We're not so much able to create lots of jobs ourselves, but by having this research facility and this capability and this know-how. Here in Australia, we think it will attract companies to come and invest here, and there's already some early signs that might be happening.
Yeah, can you share with us some of the people or some of the companies that you're actually doing work with?
Well, one company that we're working with and who is in fact building their factory next door to us is Carbon Revolution. So I'm sure plenty of people have heard about Carbon Revolution and their unique single-piece carbon fibre wheels for high-performance cars. That Carbon Revolution have really come out of Deakin University and been supported by the university, and they're doing a fantastic job of setting up their business here in Geelong, and helping us really to start to form the basis of a carbon fibre production precinct, if you like. I think also a lot of people are aware that Dow AXA, which is a joint venture between the Dow Chemical Company and AXA, which is the world's largest acrylic fibre company, that joint venture is also considering installing a carbon fibre production plant in Geelong. So we're very enthusiastic to support them and hopeful that they'll proceed in that activity.
Yeah, that's really exciting, isn't it?
It is indeed.
Yeah. So what do you spend your time doing day to day, Derek?
Well, day to day, it's really all about promoting the centre and aligning our strategy to match the needs that industry has. So I spend a lot of time now contacting companies around the world that I've dealt with in the past, and in making sure that they understand what we're capable of doing. And I mean, that's pretty enjoyable. They're often very interested and want to get quotations for doing research work. And the other thing is spending a lot of time aligning our strategies. So we've got as we're building the team and as we're building new capabilities, we want to make sure that those strategies match up with what industry partners are looking for.
Yeah, and that's a refreshing change from, it's quite some time since I was involved in universities, but the fundamental research and the connection to industry and what industry was looking for was certainly always a bit of a disconnect.
That's right.
So we've just been joined by Steve Atkiss, who's the General Manager of the carbon fibre facility there. So how are you going, Steve?
I'm very well, thank you very much. Very good to see you.
How's your wife doing?
She's improving.
Yeah.
Now she's some the right drugs, so the back's getting a little straighter.
Okay. Yeah, that's a bit of a pity. Anyway, it's great that you could make it to the podcast. So we've just been talking about Carbon Nexus and all the exciting things going on. We did touch a little bit on the production facility, which I know is your baby. So tell us a little bit more about the production facility there, Steve.
Yeah, we've got a pretty unique facility here, a 55-ton commercial carbon fibre line, which is kind of tailored to satisfy the needs of research and development in the carbon fibre world. It allows us to basically conduct experiments on every stage of manufacturing of carbon fibre. But also allow us to gain results which are, pretty easy to commercialize. So it's not, blue sky stuff. This is extremely relevant. And, when customers come to us and conduct their experiments, they know they're getting extremely good value for money.
Yeah.
And we've also got a single toe facility as well, where we basically can conduct advanced research on precursors, so new precursors coming into the market, which is very exciting. We can put them on the line, basically one spool of fibre, and then again we can oxidize the fibre, carbonize it. It's basically been a line that's been scaled down from the pilot facility that we have here, 4 to 1. So nice and slow process. And again, at every point of the process, we can extract samples, get them in the laboratory while we're running, and extract data, which we can then use the data to, focus on where do we go next, rather than guessing.
Yeah.
So, it's pretty exciting stuff. All the researchers here are blown away by the capability of the facility. Everything in the past has been done on benchtop, bucket science, shall we call it, stuff that's done in the back of the garage. And we're taking it now to the point of the results that they get are extremely realistic, extremely credible, and very exciting.
Yeah, and I mentioned earlier that I had the privilege of touring the facility last week, and certainly it is a state-of-the-art facility. It is really exciting. It's exciting to see that the scientists who work at the bench actually get to not only understand the process and as you said, extract samples and sort of relate their fundamental discoveries into real-life production, but also they get to run the production facility, don't they?
Well, that's right. They get real-life training, on-the-job training as well. But that's what Nexus is all about, is bringing industry and researchers together, which is kind of a unique thing. I mean, generally researchers have been working in their laboratories away from industry, not really understanding the full requirements of what goes on in the commercial world. And we basically bring a little bit of reality from what carbon fiber manufacturers, the difficulties that they face, the problems that they need solutions for, and it basically puts a much better focus on what the researchers' projects are all about.
Yeah.
So it's very good.
Yeah, and what I really like about it not only for the carbon fibre or advanced fibre materials industry, this is a model for research anywhere in the world, but certainly in Australia, how to gain a competitive edge research that's actually practical and relevant to an advanced industry that could be sustainable long term in Australia.
Absolutely, yes. It's a very good model, almost a blueprint for how a future carbon fibre industry should actually grow up to be. Employing the best technology, high-performance technology to make a high-performance fibre. It's not all about going for the cheap option. It's not all about flooding things with labor. This is about using technology to really, expose the capability of carbon fiber. I mean, today we've probably exposed around about 10% of the capability of what carbon fiber can offer the world. So we've got a 90% bucket to go and play with, which is absolutely fantastic.
Yeah, it's great. Really exciting stuff. So, are there things that keep you guys awake at night that you worry about?
The cost of energy. Energy is always a concern wherever you look at putting various industries. So that kind of drives a lot of our projects and is a key focus on many of our projects. They may not necessarily be totally focused on energy. They may be looking at something else, but we always try and drive the energy side of it. Reduce the consumption of energy on every single part of the process. Every single experiment you do, always have in the back of your mind that this process is going to consume energy. So we need to get that down. And that obviously has a knock-on effect on reducing the cost of a kilo of carbon fiber. I mean, historically, carbon fiber has basically been put on this pedestal of a really expensive material to use, and we're kind of questioning that, because a lot of the information that was used to come up with that term, expensive material, carbon fiber, it was based on manufacturers who were operating aging technologies, using aging techniques, not really fully understanding the processes. So, we challenge every step of the way and employ technology wherever we can to give us a visual on energy, basically converting energy into dollars so that the researchers understand that every, kilowatt counts.
Yeah. So how do you power the facility out there right now? Is it just off the grid?
It is. It's off the mains, but we have again things like emergency generator backup. Yeah. But generally it's off the mains. But we do a lot of energy recovery and also energy recovery simulation as well. So whenever we experiment, we'll always have a look at, okay, here's a handful of kilowatts that we're using to heat this part of the process. Where can we get that energy source from? Possibly using things like the abatement system, which destroys the gases, the off-gassing from the process, which we have to do to comply with our EPA standards. But that energy that's consumed to destroy those gases, we can recover this, harness it, and put it straight back into certain parts of the process.
Yeah, luckily our line is small enough that we can power directly off the grid. It's not a major user of energy in the Geelong region. A production scale factory, though, would be a very major user of energy, and that's, as Steve says, trying to find ways to reutilize any waste heat out of the process as an input back into the process is really critical in the whole exercise. I think the other thing that keeps us awake at night is just we've got this new facility, and our goal is really to attract as many companies to come and do research with us as possible. So getting our schedule full is a big priority that we have, to make sure that companies know we're here and that we're utilising the facility to the maximum extent, not having it sitting idle.
Yeah. Well, that's hopefully that opportunity will not be let go begging by industry here, and certainly, I mean, one of the objectives of this podcast is to highlight to everybody that advanced technologies are a huge opportunity, and particularly in terms of competitive advantage for Australia as well.
Exactly.
So, So what do you see as the biggest challenges then in going forward with Carbon Nexus?
Probably one of the issues that the industry suffers from is that carbon fiber historically has been wrapped up in a lot of secrecy. And trying to get this approach that we are an open access facility and getting people to believe that, and then also them coming in here, conducting their experiments and keeping all that information confidential is definitely a challenge. But the more people see us, the more people work with us, they realize that yes, it's open access, but we're incredibly secure. Breaking those barriers down, you can get access to this facility, but still will maintain the confidentiality and protect IP.
And I think it's really all about awareness now. It's a new facility. We've just opened back in May, and it's really the challenge now is to show the world what we're capable of, to show companies that we can deliver and solve their problems, to show companies that we can add a lot of value to their process by doing research with us. So it's getting out and getting the message to the world and to the local industry to really to come and participate in the activities here.
Yeah. Okay, so what role does the internet play in all of the technology and everything you do?
Well, it's interesting. The first role it plays is that for our equipment, we're very careful not to be connected to the internet, partly because of secrecy, but also because there's some technology that has to be carefully controlled and monitored. so the equipment itself and the line is kept secure. But I think we've it's through facilities like podcasts like this, through online communications. We have a pretty standard website talking about the capabilities that we have, but we're also doing a lot of international web conferencing and that sort of thing to promote the facility, and then during our programs. So we often are using Skype or web conferencing for running projects with overseas companies, so that they can essentially be here and see things, and be in contact with the researchers. And so it's about communication. It's about being closer to our customers. Australia is not necessarily in the same time zone as some of our target customers, and it helps us get closer to our customers in that respect.
Yeah, so it's reducing the world. So it's an enabler for you to basically work with people internationally.
It is indeed, yeah. And it'd be quite difficult to do that without the facilities that we've got. I mean, Deakin University, which we're part of, is really very innovative in terms of connectivity and connectedness. And so we're luckily able to participate in that and utilise that to its fullest.
Yeah, and I think that's a really important message, because we hear a lot about Australia being so far away, the tyranny of distance, and making it difficult to work with people internationally and work with the big companies that are out in the global market. But we have technology today that we can break down those barriers. All right, so what are some of the things you do then using the internet in innovative ways? I mean, you've talked about communication and that. What about the production lines and that? You said you've deliberately not connected those to the internet, but I'm sure you've got some sort of intranet or system whereby, because I know a lot of it is fully automated, whereby things are run through an intranet or something like that.
Yeah, we have it's a PLC platform that we've used, but it is completely isolated from any other facility, even in Deakin. So it's kind of cocooned inside the facility. We've got to control the information that's being generated on that line quite closely, and it's quite important we maintain that isolation. But no, it is a fully automated system using the very latest PLC platform technology.
Yeah, and a lot of that is as well as to do with intellectual property and confidentiality.
Yeah,
but I mean, the system, as Steve described it, the system is marvelous in terms of monitoring and recording all of the operating parameters on the line. So, at any time we can call up and view what's happening. We've got many ovens, as you saw. We've got several furnaces which operate at extremely high temperatures, thousands of degrees. And we can look at what's going on inside them at any given time, and we record that history. So that data is all available. And then as we report to our customers, and as people are interested to see what's going on, we have that data available that can then be utilised later.
Yeah, and as you say, it certainly is a very high tech thing that runs automated, and the beauty, as Steve pointed out earlier, you can extract samples on the line whilst it's running, conduct experiments, come back and make adjustments according to what the experiments tell you, which is brilliant. So how do you guys stay balanced? What do you do when you're not living carbon fibre?
Life without carbon fibre?
I've never heard of life without carbon. In fact, I lay up pieces of carbon fibre in my garage.
Okay, building model planes.
I like to sail yachts, and also I like to build them. So that's whenever I get a chance, I'm in the garage building a yacht and sailing, and also, as you mentioned, I like to restore old aircraft as well. So it's the engineer in me, I guess.
Okay, yeah.
I'm going through a young family phase at the present moment. I've got an 8-year-old and a 9-year-old who keep me extremely busy.
Yeah, I can imagine.
2 little girls chasing after them. So that's my life outside carbon.
Yeah. So that keeps you balanced and keeps you sane when things get a bit frustrating.
Absolutely, they bring you back down again. Although they're always interested to know what else have we put carbon fibre in today.
Yeah. Well, I did a 50.
stories.
Yeah, well, I did a 50-kilometre bike ride this morning, and I was on a carbon fibre bike, so it sort of touches everybody's lives everywhere.
Absolutely. Yeah. No, it's a lot more pervasive than people imagine. So if you play tennis, or if you ride a bike, or if you play golf, or if you ever drive across the Westgate Bridge, you're using carbon fibre.
That's right, yeah. So have you read any interesting books lately that you'd like to recommend to our audience?
Interesting books. I haven't personally.
I read a lot of history and that sort of stuff. But one history book that I did find really interesting, which might be of use, is a book which had I forget the name of the book. I think it's called The Mathematicians, but it's basically the life story in condensed versions of about 20 of the world's greatest mathematicians. Who all sort of appeared around the 1600s or the 1700s. And what was really interesting was that these guys actually, even though they were in Italy and the UK, or England and France and Germany, they all communicated with each other.
Oh, okay.
Which I wouldn't have expected. So a lot of these guys, Newton, they were writing letters, or they were looking at publications. A lot of the publications in those days were in Latin. That was the common language around Europe for scientific communication. But it was fascinating to see how these guys fed off each other and how their ideas really built up, or, they were, somebody had a question and all of these guys went out to try to answer it. And, it all began with a question. And then the fact that these guys, of course, all of them were extraordinary in terms of how they could think. And probably the opposite end of in terms of how they could communicate or get on personally. But that was a really interesting book that I thought was great, and how they really innovated in developing their ideas by feeding off each other.
Yeah. Well, there's a big message there, really, isn't there? Because you think of these guys as, Newton and so on, as they're amazing geniuses, and you kind of think of, they did this amazing stuff in isolation. They didn't. They, as you said, they fed off each other. So there's a message to that today with all the modern communication and that we have. There's a lot of synergy to be learned by, sharing information, by sort of feeding off one another and building on a platform. So don't just try and do it yourself.
Exactly, that's right. And those guys had to wait months for letters to go to and from, and they had to wait years for publications to come to them, whereas in our environment it happens overnight or instantly.
Almost instantly.
So, that's right. So you can understand why innovation and development has accelerated.
Yeah, that's right. So if you could wave a magic wand right now and fix something in the business at Carbon Nexus, what would it be?
I think we'd like to see every carbon fibre company lined up around at the front door, and every company that uses carbon fibre lined up at the front door. But more importantly, it's the companies that don't use carbon fibre who we want to learn about it. And as Steve said, there's a lot of energy that goes into making carbon fibre. As we solve those problems and make carbon fibre less expensive to produce, and as we solve the problems of manufacturing parts out of carbon fibre and make the part production process less expensive as well, then we think carbon fibre is going to move into areas where it's previously not been used before, and that's really the interesting thing for us. So it's seeing companies who don't use carbon fibre today suddenly understand the value that it offers to them, whether they need something that's lightweight or strong, or has particular electrical properties or shielding properties. There's a lot of ways that carbon fibre can be used that we're sure will revolutionise a lot of industries.
We also need to get the message across as well quite clearly that there's more than one carbon fibre. There's as many carbon fibre types as there are steel types or alloy types. I mean, here at Nexus, we could probably invent a different type of carbon fibre every hour with the adjustments that we can make to the process. And the important thing is we can tailor this material to the end-use component. So it's not a case of you're subjected to having to go to a catalogue and extracting a material that's available on the market. If you've got a fairly large volume of this fibre required into a certain product, we can tailor that, get a recipe evolved out of our systems, which basically, is tied in with the education of how did you make it, how much did it cost, what else can you do with this particular recipe in the future? So you're future-proofing your own material. Yeah. So it really is education. It's getting to know the material, getting familiar with the terms that we use, and also getting connected with potential partners. To collaborate developing your product. There's a lot of people involved with making a component, for example. It's not just one party involved or two parties. There's usually 5 or 6 different parties that are involved, right from the beginning of designing the component up to the point of actually fitting it to a vehicle and even driving the vehicle. So education and collaboration.
Yeah. Okay. Well, there's a lot of good messages there. I mean, it comes back, that collaboration and exchange of ideas and experience, coming back to the book that Derek mentioned about the mathematicians. That's always how even the geniuses made progress, and also in terms of the possibilities with carbon fibre and tailoring the material to an application, because the flexibility there must be a lot greater than making steel, different steel types or making different alloy types.
Well, that's right. This is, when you talk about advanced manufacturing, you want to be using materials which are actually designed to do what you want. Of course, steel, it's primarily a refining process where you start with an ore, and then you can, of course, blend and mix it and tailor it to suit your requirements. But carbon fiber, we're actually starting with the molecule. We're designing the acrylonitrile molecule, polyacrylonitrile, and then we're turning that into a fibre, and then we're turning it into a carbonised fibre with the strength and the tensile properties that people are looking for. So it's really in this new world where we're actually making materials according to what we need, rather than digging them up and refining them and having to just use what's available. Yeah,
and that really is exciting. Yeah. All right, well, that's terrific, Derek and Steve. So let's move on to the buzz I'm calling our innovation round, which is really designed to help our audience, who are primarily innovators and leaders in their field, with some tips from your experience. So it's kind of like a series of about 5 or 6 questions with, hopefully you'll give us a 1 or 2 line answer that will absolutely blow the audience away and inspire them to do some stuff. So the first one is, what's the number one thing anyone needs to do to be more innovative?
I think it's, the simple answer for me is ask more questions. Don't just take things for granted. Ask more questions. Why is this red? Why is why does the chair not move out from under the desk correctly? Why when I sit in my car, why can't I see out properly? All those sorts of things, and it's simply by asking those questions rather than just taking things for granted that you start to say, well, maybe I should have a camera in my car that shows me every angle and where's that pole that I'm about to strike without being able to see it because it's too short. So it's, for me, it's just asking more questions. And sometimes you need a structure or a process to ask the questions because you don't always think of the right questions. Right. But that, for me, that's where innovation comes from.
The point I quite enjoy. I enjoy people, and I enjoy looking at the skills that people have and discussing problems and issues that are out there in the world today, and listening to their opinion, even though they're not related to something like carbon fiber. You start talking to them and throw out a problem to them. You never know. There's no such thing as a stupid comment or a stupid question. If you listen carefully, there's little bits in those questions that might just spark something off. And as I say, it can come from a diverse field of people. So don't work in isolation. Talk to people and discuss the problems openly. Try not to bore them, but can't be carried away with our carbon fiber thing. Yeah. But it's taken interest in some of their things as well. Share your ideas on how you solved a problem or you come up with a solution. Be diverse.
Yeah, that's a great suggestion, because I was talking to, and we'll publish this interview tomorrow, with Johnson Onking from Pacific Paints in the Philippines, and they've got this fabulous product that absorbs nitrous oxide from the atmosphere and actually reduces the level of gases in the atmosphere, and they've commercialized this in the Philippines, and that came about from the catalytic converter industry. because that's, you know, they used technology that was being used in there, and they asked why, and they said, well, what if we put this into a paint, and how could we make it into a paint that actually worked in the way that we want it to work? So yeah, that's a really good lesson. And it's a little bit like, you know, as 2 and 3 year olds, we're all out there, why, you know, and ad nauseum almost, and unfortunately, you know, the parents like us older people get fed up with that, and we at some point you get the just because, that's all. So we kind of train people not to do that, don't we?
That's right. At some point we stop asking why.
Exactly, yeah.
That's one of the great, you know, in terms of generating ideas, that was one of the tricks that I learned at GE, is actually you have to continually ask why, and you ask why 5 times before you can be satisfied with an answer that you might have. So the rule of ask why 5 times.
Yeah, that's great advice. Thanks. What's the best thing you've done to develop new ideas or products, or, you know, some new things around what you're doing at Carbon Nexus?
For me personally, is I've been quite fortunate. I haven't got myself stuck in a rut and stayed in one specific area. I've moved all the way through. You know, coming into carbon fibre, I started off as a resident engineer on a building site, building a carbon fibre factory for a company, for SGL Carbon Group. And, you know, eventually they said, would you like to come on board and be our maintenance manager? So I said, yeah, sure, I'll do maintenance, no problem. In my youth, I was a maintenance technician in the Royal Air Force, so I had a few skills there. Then they said, how do you fancy taking on the engineering manager role? So it's like, okay, that's a movement up into a slightly different area. A few years after that, it was, how's about running production? Now, crossing over from engineering into production is like moving from one country to another. It's 2 different cultures. There's usually 2 big barriers up and a few walls in the way. But it was great to go and kick those walls down and take the engineers with us as well, and the technicians with me, into production, and show them there's another angle that you can actually go into and get good results from when you've got exposure and understanding as well. And then taking that, going into design, and now I'm into research. So, you know, covering many, many bases. Don't get stuck in a rut. It's my basic message for that one.
Yeah, that's great advice. And it brings up, in my mind, the idea of cross-functional teams as well, because, you know, the traditional model within industry is kind of everybody's in silos, like you've mentioned, you know, the production guys and the engineers and the research people and so on. So the idea of cross-functional teams, which does necessitate people moving around into different roles.
Yeah, that's why Nexus is kind of so exciting, because you have that again. There's this cross-function of having researchers getting really heavily involved in industry, and then we bring industry partners in who get heavily involved in research, so we can all see the value of each other's role in this industry.
Yeah. The thing for me that I've always found valuable to develop new ideas or new products has been not only the cross-functional team, but also people with different viewpoints. So whether that's you know, physically diverse in terms of different countries or different cultures or different religions or different races, it's always good, I find, to have people with different viewpoints to generate different ideas, because if you've all got the same background, you know, you answer these questions the same way. And it's when you've got people who've got different experience and different backgrounds that they answer the questions in different ways and generate more ideas than you would have if you just had all the same people. And I guess it's the same thing as cross-functional teams as well, that they're approaching a problem or a solution, or trying to find a solution from different perspectives. So it's those different perspectives and bringing together those different perspectives, I think, that always helps. And, you know, in GE, I was lucky enough to work in a lot of different countries and different roles as well, but I always tried to pull together a diverse team, men and women, you know, different country backgrounds, different ages, and you'd always get a better outcome. Yeah,
that's great advice. Yeah. So you mentioned earlier, Derek, about a structured process for asking why and a structured process for following through ideas or investigating things. Do you have a favourite tool or system you use there, or is it something you've sort of built internally?
There's a few brainstorming techniques to try to tease out ideas. You know, I think the tool I find the best is actually the post-it. Because what you do if you're brainstorming or looking for ideas, give people 5 minutes to work in silence, and write their ideas down, and then put them on the board. And that way, the shy people in the room are not handicapped or not taken over by the boisterous people in the room. So that's a great way to get to tease people's ideas out. Say to people in the room, right, I want three post-it notes from you on what we could do or how we could solve this, or what questions should we ask, or who can we go to. So giving people the opportunity to work. First of all, it's silence, if you like. Writing down what they would think, and then you make sure that you've got the sort of democratic process to go through and give everyone their space and their time. The other tool I like, being a mechanical engineer, mechanical engineers are designers and inventors by training. That's what you learn about how to do, and there's lots of processes there. But one of the processes that I didn't learn in university was one called predictive design. Mm-hmm. And that's a really interesting process whereby instead of just writing down a design equation or designing a part, given certain assumptions, what you do is you inject uncertainty into the assumptions. And you may do that in some sort of computer simulation where you're injecting probabilities of different outcomes, versus an exact number for a particular outcome, or you're injecting, probability distributions for the stress loadings instead of just one number for the stress loading, or it could be that you're looking at a whole lot of different people in terms of what height should we be designing this particular product for, or what age group, So thinking about predictive design and how do you take uncertainty of your assumptions and put that into your design process.
Yeah, that's a fascinating technique. And I could see that applying across the board in business, business applications, not necessarily engineering applications as well.
Oh, indeed. Anything you're dealing with people, any process where there's variation in the inputs and the outputs is really should be utilized in those.
And that kind of touches the point I'd like to make, and that is I love to throw engineers onto the production line. I like to get them dirty. A lot of these guys, they really do love to sit in front of the computers and bash out calculations and look at the theory and see how it theoretically should actually work. I love them to go and work alongside operators. Operators are a fountain of information. It's just fabulous when you work alongside them. They're there in the thick of it. They see the problems. They have thoughts all the time, but it's very seldom they actually get listened to, because it can often sound like they're maybe moaning about something or criticizing about something, but they're not. These guys have got some real fresh ideas, some fresh angles on things. They're not necessarily too strong on the theory behind things, but they've got some great ideas that when you marry up the engineer and the operator together, they make a fabulous team. You saw actually evidence of this on the control system, the HMI interface with the line. That was born out of the software engineer spending many years on the line itself, working alongside the operator. He got to the point where he could actually handle the majority of carbon fiber manufacturing tasks that the operator gets on with. But he listened to the operator, listened to their problems, listened to some of their ideas and solutions, and then would go away and try and make it reality. And the result is exactly what you've seen, is an interface where the operator now can do his job better, employing more technology that the operator maybe wouldn't have thought about, certain items of technology that you can actually use to make your life easier. So great results like that. But I really do believe getting dirty on the line, getting involved with existing processes, understanding those processes is a great way forward.
Yeah. Oh, that's great. Yeah, and for the benefit of our listeners, what Steve's talking about there was essentially along this production line there are a number of tablet PCs that are hooked up to the production line that actually run it. And on the tablet PC, you can switch from the interface from a process map, which is kind of the traditional way that any production line has been run in the past, you can switch to a very visual representation that looks like a picture of the production line that's in front of you. So you can actually pick a part of the production line, click on that on the touch pad, and pull up an expanded view of that particular component and have a look. For example, you can pull up an oven, you can look inside the oven, you can have a look at the fan, you can have a look at the temperature that's being produced and the speed of the fan and all kinds of other information there. So it's very visual, which of course allows people that are not necessarily engineers to visualize and make it a lot easier for them to run the line in a smart way. Does it capture it reasonably well?
Yeah, no, that's spot on. Very good.
Excellent, thanks. So what's the best way, to keep a project or a client on track?
I think regular communication and feedback. If you're progressing well against milestones, you still got to talk about what the milestones are and are they the right milestones. And if you're not progressing against the milestones, you need to be feeding back and then adjusting based on that feedback to see the different things that we should be trying. And is the client happy with all the different things that we're going to propose, because they may or may not result in the time frame. So I think it's communicating, letting people know what's going on, letting people know, and giving them a voice in the process, so that you're not just taking a problem, going away, working independently and coming back and saying, here's the solution, or coming back and saying, no, we can't solve that.
Yeah, that's great.
Yeah, I agree. And also making sure the brave guy who takes on the title of project manager is fully empowered and, as you've assessed them to be capable of handling the problems and the stresses of the job and delivering. And again, some great communication skills back up to the client and making sure the client is told the truth. There's nothing worse than being told, oh yes, we're all on schedule, everything's great, but you're actually 6 weeks behind schedule and you're over budget. So keep telling the truth and making sure you've got a great team around you. So that project manager is absolutely key. Top quality you need.
All right, thanks. And finally, what's the number one thing that you can do to differentiate yourself?
Well, we've got a great team and a unique facility, so we're kind of already differentiated. Yeah. But I think the key for us is really showing customers that we can solve their problems and that we can work with them to add value in their research. I think it's for us we're a new team, a new facility, and we need to get out there and show people that we can deliver. And I think that will differentiate us, because we've got equipment that no one else has. And we need to show people that equipment can give them the results that they're looking for on as Steve says, on an industrial, meaningful scale.
So basically, you've got the capability to A, understand your client's problems, and B, then to deliver on that because of the expertise you have. So it's not about carbon fibre, it's about solving problems for your clients.
Exactly. It's the equipment and the researchers, the people, the team. The two things go together as the unique capability. Yeah.
Excellent. Well, what do you see as the future for Carbon Nexus?
Well, we're a young team. There's been a group of people here establishing the facility, building the building, and specifying and installing the equipment and starting it up, and that's taken about 2 or 3 years. And now we're in a different phase now. We're really operational and moving out into the industry and becoming, I think the industry is becoming, they're aware that we're here. And I think now that the phase will be that they're coming and trying things out and actually seeing the benefits of working together with Carbon Nexus. So I think the future for us is continuing to align our capabilities with what industry is looking for. But at the same time, bringing some new things. So we want to do, research that helps solve the questions and the problems of industry today. But we're also doing research which is going to be solving how to take carbon fibre into the new applications of tomorrow, as we said, with lower cost or higher strength or targeted properties or improved efficiency. There's a number of different areas that we're focusing on the fundamental level, which will take us into new areas.
And I talked earlier a little bit about this 10% realized of carbon fiber's current capacity. We've got this 90% to play around with. Executing as much of that 90% as we can is where our future is pretty well laid. And it's not just about carbon fiber, it's adding things to fiber, it's looking at the processing of fiber. There's all sorts of oddballs around it, and also obviously the end use. How can we make those components quicker? So we really want to get those components being produced in less than 60 seconds, which would be fantastic. And we want to do it consuming the least amount of energy and consuming the least amount of resource as well. So we're going to be pretty busy reducing, and then expanding consumption and expand of the actual material and putting in as many parts as we possibly can around the world.
Yeah, well, you've kind of answered my next question, actually, which is what do you see as the future of the industry, the carbon fiber and the advanced materials industry?
Yeah, basically, if it has metal in it, it's going to be heavy. Let's replace it with carbon fiber. Yeah. And that's what we see. I mean, we're almost every day we have somebody knocking at the door or on the phone or over the net talking to us about a new product. What do we think about this? What do we think about that? From every walk of life you can imagine. Everything from medical to sports to aircraft to cars to concrete to you name it. It's basically, if it's got metal in it, it's time to replace it.
Yeah, essentially we want to see how we can help move carbon fiber from the advanced materials industry to the standard materials industry without losing the value of the product, because of course there's an inherent value in it, but figuring out how we solve the problems of educating design engineers and making them comfortable with using composites, and solving the problems of production rates, and solving the problems of cost. So it's, so that it does, as Steve says, so that we penetrate into that 90% of potential that's still not being used.
Okay, well, that's great. That's been a really fascinating innovation round. So I'd just like to go back to our competition and remind our viewers and listeners that today I'm giving away a copy of my 7 website design secrets to get you more sales. So that's a video workshop together with a workbook and a resources guide. And in order to enter this competition, what I'd like you to do is comment at the at the bottom of the video recorder and tell us what the most innovative use of carbon fiber technology is that you know of today, and what benefits that carbon fiber is bringing to that particular application. So if you could do that and describe it in a little bit more detail, hopefully that will prompt some ideas for Carbon Nexus as well, to kind of take that and ask a lot of why questions and take some ideas away from that. And I'll get Steve and Derek to come back in a couple of weeks' time, have a look at those comments and nominate the winner of that prize. Is that okay, guys?
We'd love to. Fantastic. Yeah, very much.
All right, so in conclusion then, what's the number one piece of advice you'd give any business who wants to be a leader in innovation and in productivity?
Keep asking those questions. Don't accept the status quo.
Yeah, no, I totally agree. Keep asking questions and open your mind. Keep your mind wide open. Just because you've done something like that for 10, 20 years doesn't mean it's the right way of doing it. So, and talk to people.
Yeah.
Talk. Yeah.
That's great. Yeah, great. We never stop learning, do we?
That's right.
Yeah. All right. And finally, who would you like me to interview on this InnovaBuzz podcast in the future, and why?
Well, there's a new question that we haven't thought about. There's some I would be looking for groups similar to ourselves where there's good links with industry, because they're out solving practical problems. We came across a gentleman from Sydney University yesterday who had some very interesting applications of some new polymerization technology. So that was Brian Hawkett from Sydney University. I think he would have some interesting stories to tell.
Okay. All right, Brian, look out for your inbox in email or on LinkedIn. I'll try to connect with you and invite you to a future episode of the InnovaBuzz podcast. So thanks for that. Now, gentlemen, this has been absolutely fabulous. It's fascinating, and I'm really excited by the stuff you're doing at Carbon Nexus, and I'd like to thank you again for spending time with us today on the InnovaBuzz podcast. I wish you all the best at Carbon Nexus. I'm really excited to see what develops out there and what direction this great initiative takes. Now, where can people reach out to you and say thank you for the time and the information you've shared with us today?
Well, you can find us on the web at carbonnexus.com.au. It's pretty easy to find us. Or if you're passing by Deakin University, we do welcome industry visitors to come through at certain times. So that's how to find us.
Okay, and I'll certainly post the link to that website underneath the video here on the post. Yeah. So thanks again, Steve and Derek. It's been a pleasure.
Thanks for your time.
Thank you very much indeed.
I hope you enjoyed meeting Derek and Steve as much as I enjoyed interviewing them on the podcast. I learned a lot about Carbon Nexus, and of course previously I had the opportunity to visit the facility and see the production lines. Derek did say in the interview that they welcome visitors at the centre, so contact them via their website if you would like to arrange a tour. Of course, you can subscribe to the InnovaBuzz podcast via iTunes or Stitcher so that you will never miss a future episode. All the show notes for this episode will be at innovabizz.com.au/Carbon Nexus. That's CARBONNEXUS. All lowercase, all one word, innovabizz.com.au/Carbon Nexus. All of the links and everything we spoke about in this episode will be there. Remember, leave your comments underneath the video for your chance to win a copy of our 7 website design secrets to get you more sales video workshop series, together with the resources guide and workbook. Leave a comment under the video and tell us what is the most innovative use of carbon fibre technology that you know. And tell us what benefits carbon fibre is bringing to that particular application. I'll get Steve and Derek to come by in a couple of weeks' time and have a look at those comments and award the winner of the prize. If you like these podcast episodes, we'd absolutely love it for you to go and give us a 5-star review over at iTunes, because that will really help us get more listeners. So until the next time, remember, if you don't innovate, you stagnate. So think big, be adventurous, and innovate on.